Year 10 Standard Form Lesson 1. So we're going to start off by reviewing work that you have covered previously, and we're going to look at how we write numbers in standard form. So let's start off with large numbers to begin with, and then we'll look at smaller numbers a little bit later on. So each of the numbers that I'm going to write down are in what we call ordinary form. So for instance, let's start with our first example. We're going to start with a very easy one to begin with, which is simply 4,000. Now, we're going to write this number in standard form. So to do that, I'm going to first of all rewrite the number as 4 multiplied by 1,000. Now, to convert this to standard form, I then need to write the 1,000 as a power of 10, and that of course is 10 cubed. So here's 4,000 in ordinary form. And here's 4,000 written in standard form. One way of working out the power of 10 that you need is to put in your imaginary decimal point here, 4 or 4.0, and we have to jump once, twice, 3 times, because we need to multiply by 10 3 times. Let's choose another number. I'm going to choose a much larger number, 23 million, and we're going to convert this to standard form. So the first thing that I need to do is to make sure I focus on these digits here at the start, the 23. Now, if I'm writing a number in standard form, the first part of that number has to be between 1 and 10, not including 10. So that means rather than 23, I need 2.3. How many times do I need to multiply by 10, though, to create this number? Well, that's 1, 2, 3, 4, 5, 6, 7 powers of 10 that I need to multiply by. So it's 2.3 multiplied by 10 to the power of 7. And your power of 10 will always be the number of jumps that you make, because that represents the number of times you need to multiply by 10. Let's try another example. So this time, 361 million. So the first part of my number is going to be based on the 3, the 6, 1 here at the start. I can't have 361. I can't have 36.1. I've got to have 3.61. Now, we need to multiply that by 10 a certain number of times. How many times? Well, put in your imaginary decimal point there. 1, 2, 3, 4, 5, 6, 7, 8. So that's 3.61 times 10 to the power of 8. Let's do another example. 425,000. Smaller number. So look at the 425 at the start. How could we base that on a number between 1 and 10? Well, 4.25. Put in your imaginary decimal point there. How many jumps? 1, 2, 3, 4, 5. So we know that we need to multiply by 10 to the power of 5. Now, what would happen if we had a very much smaller number? For instance, 5,240. This is not the sort of number we would usually write in standard form because it's so easy to write down in ordinary format. Numbers that we write in standard form tend to be very, very large or very, very small numbers with lots and lots of zeros in them, and it makes it much easier to write them in standard form. So look at the 3 digits here, 524. I'm going to need to write 5.24, and this is then going to be times 10 to the power of, well, let's see, put in your imaginary decimal point, 1, 2, 3, times 10 to the power of 3. So let's just write down a quick note about numbers in standard form. So if a number is to be expressed in standard form, it must be written in the format you can see here. So the green square represents the first part of the number, and this must be a number between 1 and 10, but not 10. So now it's your turn. Can you write each of the following numbers in standard form? Make sure you pause the video. The answers will come up in a few seconds. So here are the answers. Some of you might be worrying, for instance, in part B, why I've written 2.0 times 10 to the 6 instead of 2 times 10 to the 6. There's absolutely no difference between the two answers in this particular context, so it's absolutely fine. If you've put 2.0 times 10 to the 6, that's correct. If you've put 2 times 10 to the power of 6, also correct. And the same in these other questions as well. So we're now going to have a look at how we can write small numbers in standard form. And we're going to start very simply with 0.03. Now, to start off with, we need to choose a number between 1 and 10 to represent this. So that's going to be 3 or 3.0. Now, we then need to ensure the second part of this is complete, so times 10 to the power of. Now, this time, because it's a small number, it's going to be a negative power of 10. Imagine you have 3.0, so a decimal point would be here. That's once, that's twice, so it's 10 to the power of negative 2. Now, what does this actually mean, 10 to the power of negative 2? Well, you've just recently had a look at negative indices. So this means 3.0 multiplied by 1 over 10 squared. So that's 3.0 multiplied by 1 over 100, which is the same as saying 3 over 100, which of course is 0.03. So the negative powers here ensure that you are multiplying by very small decimals, which is how you can write these numbers in standard form. Let's take a look at another small number. So this time 0.00006. So the starting point of this number is going to be 6.0. You can write 6 if you want to. I quite like putting the decimal point in because it helps me work out how many jumps I need to make. So if there's a decimal point there, that's 1, 2, 3, 4, 5. So it's 6.0 times 10 to the negative 5. Let's do a few more examples. So 0.000307. So focus on this part of the number. It's got to be written as 3.07 times 10 to a power. Let's put in an imaginary decimal point there, and then let's count 1, 2, 3, 4. So that's times 10 to the negative 4. We'll do one last example, which is 0.0000230. Now, the 0 here doesn't really provide much information or value. The numbers that we're going to look at are, of course, here, and we're going to write that as 2.3 times 10 to a power. And if I put in this imaginary decimal point here, that 0 at the end of the number here doesn't really have any effect. So 1, 2, 3, 4, 5 times 10 to the negative 5. If you wanted to, you could write this as 2.30 times 10 to the negative 5, but again, that 0 at the end doesn't really give you much additional information. So now it's your turn. I'd like you to write each of these numbers in standard form. Remember to pause the video and then check your answers when you are ready. So here are the answers. Again, in examples like A, if you've written 2.0 times 10 to the negative 3, that's correct. If you've written 2 times 10 to the negative 3, also correct. And this will be the same in some of the other examples as well. So we're now going to have a look at how we convert numbers from their standard form to their ordinary form. And we will look at a few examples to illustrate this. So let's start with 2.4 times 10 to the power of 3. So my advice when looking at a question like this is to start off by writing out the 2.4 and then thinking about the fact that it's times 10 to the power of 3, and every time you jump, that means you're multiplying by 10 each time. So that's once, twice, 3 times, and then that gives us an answer of 2,400. Let's try another example. 5.17 times 10 to the power of 6. So I'll write out 5.17 and then I'll make sure that I jump 6 times. So that's once, twice, 3, 4, 5, 6, each time representing another multiplication by 10. So this then gives me my answer of 5,170,000, and there we are. Now let's have a look at some smaller values. So for instance, 4.3 times 10 to the negative 5. So because it's a small number, the jumps are going to be in the other direction. I'm going to write the number over here to make sure I leave myself some space to do this. So times 10 to the negative 5, that's once, twice, 3 times, 4 times, 5 times, and this gives me the position of my decimal point. I then need to go and fill in all the zeros are representing each division by 10. So my answer to this question is 0.00043. Let's do one last example, which is 2.5 times 10 to the negative 4. Start off with your 2.5 and then let's divide by 10 once, twice, 3 times, 4 times, and fill in some zeros. So my final answer, 0.00025. So you're going to have a look at some practice questions yourself now. So here are the questions for you to have a look at. Make sure you pause the video and then check your answers once you've completed all the conversions. So don't forget to finish off by checking your answers and asking if you're not sure about anything.